Segala yang bermula.
Assalamualaikum. Hi. In this Mechatronics EMC 311 projects, we were given a task to develop a material handling system by integrating various sensor and actuation system using Raspberry Pi microcontroller. We were required to design a system to move the conveyor belt so that the container with the metal plate can receive the ping pong balls discharge from the feeder. The sequence of the flow were developed and designed by programming the codes.
Hello, Assalamualaikum. I'm Halimaton. I will do the introduction of this component. There are 6 input and 6 output. The first input is red switch, light switch, proximity sensor, 4, 5 the magnetic sensor here, and the last one is the digital humidity and temperature DHT22 sensor. Okay, we go to the output part. It consists of 3 double acting cylinder connected to 5 two-directional control valve and 1 single acting cylinder connected to 3 two-directional control valve. Okay guys, for output, and the last 2 output is the relay here, relay A and B. It's used to control the conveyor belt movement and direction. Here is the controller for the speed of the conveyor belt. Okay, it is the feeder to channeling the ping pong ball. It is the interface circuit. And last it is the PLC input port and output port. Thank you. Hello, I will talk about our design box. The design of our box is designed according to the width of the conveyor belt and the height of the proximity sensor. This box is made from used corrugated box, and this metal strip is from aluminum can, and this transparent cover is from the stationary packaging. Thank you.
Hello, I'm Goh Su Teng. I'm going to explain about wiring. So start from PLC. We connect 2 wires, one is brown, one is grey. One from the positive terminal, one from the negative terminal. Positive terminal we connect to whole block of connection with serial connection. So this whole block will be for 24-volt connection, and for this one is for ground connection. Because of less connection, we also use breadboard as our ground terminal to connect. So every red wire of the sensor and solenoid we connect to the 24-volt series, and for the sensor part they have 3 wires, one to the 24-watt, one to the ground, and another one we connect to the interference board to connect with the GPIO. For the solenoid part, we connect one to the 24, another to the interference board. From the interference board, there are wire connect from foreground to the negative terminal that we extend from here. So from the interference board, each of the equipment will have respective GPIO connected to the Raspberry Pi. So here is for the solenoid, relay A, relay B, sensor, and this is the respective GPIO for sensor. So for the humidity sensor, they have 3 wires, one connected to the positive terminal and one for the negative terminal, and another one we connect to the Raspberry Pi for its own respectively GPIO. So that's basically how the wiring goes.
Hello, my name is Poh Ling. Now I'm going to explain about the coding part of our project, which is material handling system. Firstly, we will import rpi.GPIO module to control the GPIO pins. Next, the time function is imported for delay purpose. The third one is import DH222 library to activate the DH222 sensor. Now come to the setup part. All the input-output are assigned to respective GPIO of Raspberry Pi. There are 6 output and 5 input in our material handling system. All the solenoid and relays are assigned as output, while the sensor and switch are assigned as input. GPIO 14, 15, 33, 34 are assigned as solenoid. High condition is mean that the piston is in extend mode, while the low condition is mean that the piston is in retract mode. GPIO 5 is assigned as relay A, which is used to control the movement of the conveyor belt. High condition is mean that move the conveyor belt, while the low condition is mean that stop the belt. GPIO 6 is relay B, is used to control the direction of the belt. High condition is means that move to the right, and low condition is mean that move the belt to the left. Proximity sensor is assigned as GPIO 17 and 27. True condition means that no input are detected, while false condition means that input are detected. Red shields and black shields are assigned to GPIO 2 and 3 respectively. True condition means that the button is not pressed, while the false condition means that the button is pressed. Next is the read DH322 function. It mainly used to activate the DH322 sensor and read the humidity and the temperature. It will call out in the main body later. This is the main body function of our coding. While loop is used for infinity loop of the system, the read DH322 function is called out and bring humidity and temperature every 3 seconds. Now come to the material handling coding. GPIO 2 false means that the red button is pressed. All the solenoid are in high mode, which is in the extended mode. Both GPIO 5 and 6, which is relay, are high to move the conveyor belt to the right. When the GPIO 17 is false, which means left proximity sensor detect input, GPIO 5 and 6 are in low condition. The belt will stop moving. The top left piston 1, which is initially in the high mode, will change to low, which means from the extended mode to retract mode for 1 second and extend it again for another second. So this is bottom left piston 2 in low mode, which means it start retract for a second and extend for another second to drop the first ping pong ball. This process will repeat to drop the second ping pong ball. Then both relay, which is GPIO 5 and 6, will in high mode again to move the belt to the right direction. The system will bring 2 balls are collected. When GPIO 27, which is right proximity sensor, is false, which means it's detected input, both relay GPIO 5 and 6 in low mode to stop the belt. Top right piston 3 is low to retract for a second and high to extend for another second. Same goes to the bottom right piston 4. Retract, which is low mode for a second, and extend, which is high mode for another second to drop the third ping pong ball. The process will repeat to drop the fourth ping pong ball. Then the GPIO 5 is in high condition, while the GPIO 6 in low condition to move the conveyor belt to the left direction. Until the GPIO 17, which is left proximity sensor, is false, which is detected the input. Again, the GPIO 5 and 6 are in the low condition. The belt will stop moving. The top left piston 1 in low mode, which retract for a second, and high mode extend for another second. The bottom left piston 2 also the same. Low mode, which means it start retract and extend for another second to drop the fifth ping pong ball. This process will repeat to drop the sixth ball. Then both relay are in high mode again to move the belt to the right direction. Again, the GPIO 27 detected input, which is in the false condition. Both relay are in low mode. The belt will stop moving. The piston 3 and 4 change from low mode to high mode for retract and extend purpose to drop the 7th and 8th balls consecutively. The GPIO 5 in high mode and GPIO 6 in low mode to move the belt back to the left direction. The system will bring 8 balls are collected. Now GPIO 3, which is black sheets, is in false condition, which means you press the red button. The relay GPIO 5 and 6 are in the low condition. The conveyor belt will stop.
So after we've done all the wiring and the coding parts, then let's start our process. So firstly, when you press the red button, the box will moving to the left. When the proximity sensor sense it, it will drop 2 ping pong balls from this cylinder and move to the right part. After reach the proximity sensor, it will drop consecutively 2 ping pong balls, and then it will move backwards until here, sense the proximity sensor again and drop 2 more ping pong ball, and moving back to the right position, it will drop another 2, so total 8 ping pong ball is collected in the box. Then we will press the black button to stop the conveyor belt. That's all from our process. Thank you.
So it's the end of our project. What we can learn throughout this whole entire project is that we can actually use this and apply into real life. And then some of the skills that we learn, which is Python, Raspberry Pi, we get to use it inside the PLC. And then not just quite yet, we actually get to integrate a pneumatic system, actuation and also the sensors into one goal, which is to release the ping pong ball into the material handling system. So I would like to take this opportunity to thank all the technicians and also our lecturers and also everyone who actually helped us, and we had a very fruitful memory together as our team and able to come out with this project, and thank you guys.